Hello, my name is Matt Voget, and I'm excited to talk with you all today about conquering the API Rainbow Road level with these dev cheat codes. Or put another way, what are 5 ways in which we, as API developers, can create higher quality APIs? So, just a little bit of background about myself. I'm the VP of Engineering at Ambassador, and before that, I, you know, built a lot of APIs as a software engineer. Anything from RESTful APIs, GraphQL APIs, and SOAP. Um, and so I've been through a lot of challenges when creating these APIs, and so I'd like to share kind of from my perspective some of the challenges that I've run up against, and then also kind of take a look forward too, and how can we build better APIs, especially in this age of AI. So our agenda for this talk today, we're going to start by talking about some of the challenges in API development. And I think 2 of these challenges reside around 2 themes, one being lack of API specs, as well as how can we optimize our developer experience or ways in which we can be more productive when we create our APIs. And so here's a quick sneak peek at the 5 cheat codes that I can offer to help solve these challenges and bring better API development. But I'll get into more details on those as we go. So what are some of the challenges that we have? So the first class of challenges, I think, is that we're missing API specs. So 71% of traffic on the internet is done through API calls. However, 85% of developers say that they have a RESTful API, but less than half of them say that they have open API specs. So taking those 2 stats together, we've got a lot of traffic on the internet done through API calls, but not a lot of them have API specs associated with them. What's more is that in this age of AI, right, and the age of MCP servers, a study found that 80% of enterprise AI agent frameworks are going to use an MCP style of service discovery by 2028. So if we put all 3 of these things together, we've got a lot of traffic on the internet done through API calls. We'll probably have MCP servers using these APIs to expose that data, but not a lot of those APIs have API specs. So that kind of raises a lot of red flags for me. Like one, for example, being how can we be sure what these AI agents are going to be returning to clients and users without having a spec to describe the API? So let's break it down a little bit. I realize I'm kind of preaching to the choir here, but what are API specs and why should we care about them? So they obviously API specs are things that can define the contract, the API contract between a server and a client. They can really be used as a source of truth for validating that contract. But they're also useful in promoting governance around API development, as well as ensuring that we're following best practices, especially with things like security. Um, but I think that specs are even more important now today than they ever have been because they're blueprints that things like AI and other tooling can use. So if we think about things like code generation or creating a test harness or automation testing or even having like security scanners, API specs are very important to serve as these blueprints for our APIs so that other tooling can use them. So what happens when we're missing these API specs? Well, I think first, obviously, we can see a lot of integration issues or uncaught bugs in production if we don't have specs that help us with our testing. We can also see gaps in security too. So for example, is this endpoint protected by a security scheme? Well, it's hard to tell unless you have a spec that kind of asserts that truth. Or even worse, should this endpoint be publicly exposed, right? Hard to tell, again, if you don't have this thing in a spec, right? If you should be revealing this endpoint or not. So missing spec not only leads to uncaught bugs and things of that nature, but also poor developer experience. And I'm not talking about developer experience specifically for humans, but also for things like AI agents, which will, eventually be these heavy consumers of these APIs. So a bad developer experience for AIs, for example, may at best lead to bugs where it just doesn't work, and at worst could lead to things like massive data leaks where the AI is using endpoints that it shouldn't be using or exposing data it shouldn't be using. So all that to say is that um, we have even more challenges in this AI world, and I think that missing specs is not going to help us. So let's kind of pivot to the other side of the coin of API development here and talk about these things called development loops. And so, our challenge when creating APIs is how can we be productive, right? As we go through our development life cycle. So I like to picture things as like two development loops. There's this inner loop and this outer loop. So on the inner loop, we've got things like a developer might do every day when building an API. They'll write code, they'll build that code locally, they'll try to test it out, debug things that might be happening, and then eventually get to a point where they commit that code, and then they enter this outer loop of development. So the outer loop, think in terms of like CI, right? I've got CI workflows that will um, run automation tests or deploy my changes into an integration environment so that my team can test them out, right? And then eventually we'll deploy those changes into production. So if we're thinking about productivity and these development loops, we want to keep this inner loop as fast as possible because the developer is going to be executing it multiple times when creating something like an API. When we think about the outer loop, it's going to be slow and it's going to be done remotely. So we want to make sure that we avoid running that outer loop multiple times. So think about finding a bug in an integration environment, right? You're going to have to make those bug fixes locally and then push them back out again to this outer loop in order to get them redeployed. So we want to execute that outer loop as few times as possible. We can also think about these infra trade-offs too when it comes to developer productivity. So for example, speed versus quality, right? Let's say I have an application that's composed of a lot of different microservices, and me as an API developer, I want to, change a microservice, but then test it out to make sure that it works with the rest of the microservices running in my full application. So there's this speed versus quality trade-off, right? If I want to do fast iterations on my inner dev loop, I might have to sacrifice the quality of my development environment to make those changes, right? Because I don't want to run the full stack of microservices locally every time I make a change. Conversely, if I wanted to get that super high quality testing, want to run the full stack of my application to test my change, but that really, really slows down my inner development loop, right? Similarly, we also have this autonomy versus skill set trade-off that we have to consider. So to kind of describe this, like it's hard to build out like a team of developers that can both, have all the dev skills that we need to create these APIs, but then also have all of the infrastructure skills, things like, Kubernetes experience, right? Deploying your application into infrastructure. So it's kind of a unicorn of a team when you think about it. So oftentimes we have to make these trade-offs with our teams too. So, we can have a different team. So what usually ends up happening is that we'll start to form these siloed teams where, there's one team that's like a product feature team who, has engineers who can code, right? But then you also have a separate DevOps team or a platform team who are the infrastructure experts. But these siloed teams can really lead to a lot of productivity challenges down the line. But how do we combat these problems, right? The missing API specs as well as some of these developer productivity challenges. So let's talk about these 5 cheat codes that we can use to help solve these problems. So the first one is let's use AI-driven API specs. And what I mean by that is that, I think that AI is still, it promises a lot, but it's still kind of in its infancy when it comes to some areas. Like we may not trust it fully to generate large scale applications or perform complicated coding tasks. But I think where we can really leverage AI is in creating and maintaining our API specs. So it's really, AI is actually really well suited to following that rigid structure of, say, an open API specification, right? And generating the content to follow that rigid structure. So imagine, if you will, like typing in some of these prompts into AI, right? Like create an API spec from my code repo. It can scan all of your code files and kind of propose a specification for you. Or, modify my API spec to include better examples. It should be easy to follow that pattern of open API and put those examples in. Or find any endpoints missing a security scheme, right? AI is really good at that pattern recognition and, trying to apply that same kind of pattern that you have maybe in other API specs into your current one. So this is really exciting for me because I'm someone who used to work at Stoplight, which I think is now owned by SmartBear. But I was working on that form-based spec creation tool, and so it's really cool for me to see how far we've come when it comes to creating open API specifications. I think as some simple chats or prompts, right, to AI can produce some pretty amazing things. So I think that we're kind of running out of excuses for why we all can't quickly and easily maintain and generate these API specs. So cheat code 2, we should base our mocks on these specs. So oftentimes today, we spend a lot of time creating and maintaining, I would say, bespoke mock servers. So we might use things like proprietary tools to create our mock servers, to create our mock responses and things like that. It could be really burdensome to have to update and maintain these mock servers as we go too. So, let's say, for example, I have to change my API, change some kind of model within my API, and now I need to change, for example, all of my Postman collections to update that. It can be kind of a burden. But we know that mocks are really important because mocks can enable parallel development. My backend team and my front end team can work at the same time. If we have mock interfaces or the interfaces mocked out, we can also remove live dependencies from testing as well by just stubbing or mocking out those dependencies. And we can use mocks to power things like API dev portals. So I think that what we should start to lean into more is if we can easily create our API specs, let's quickly create our mocks directly based on those API specs. And in that way, it's way easier to maintain. Any changes to the API should result in a change to the API spec. And as soon as the API spec changes, we should be able to update our mocks automatically. So I think this will lead to high quality testing, higher quality mocks, because we know that our mocks are based off of that API spec. And we should also remember too that like our applications may not be dependent only on internal APIs, but also on third-party APIs like OpenAI or Stripe or Auth0, for example. And those dependencies also typically have API specs themselves, which we should be able to quickly convert into mock instances. So if we can arrive quickly at the high quality API specs, I think we can arrive quickly at high quality mocks as well. So cheat code 3, embrace workflow testing. So let's remember the testing pyramid for a second here, which you may have heard of. But at the base of this test pyramid, we usually put things like unit tests, and then kind of as we go up the pyramid in the middle, we've got integration tests, which kind of test different components together, right? These different units put together, and then at the top of this testing pyramid, we have things like end-to-end tests. So similar to mocks, we may be setting up our testing strategy in pretty bespoke ways that can be a pain to update and maintain whenever things like APIs change. Um, so for example, let's say I change, the API for a really core function, like the schema for a user object, for example. And now, I need to go and change a dozen of end-to-end tests that all rely on that, same API or that schema. So how can we apply this type of thing to APIs? So I like to think of open API specs as ways in which we can test the API units. So for example, I want to validate that my endpoint is returning the expected response body. Um, and so I can treat that like a unit test, right? Um, but oftentimes we need to string together multiple of these API calls to accomplish something that's more functional. For example, let me I want to get a user profile, right? So what do I have to do to do that? I would have to maybe authenticate with an API and obtain an auth token. And then I might have to get a list of all users by their IDs, which could be a call to another endpoint. And then I might need to call a third endpoint to fetch the profile of a given user by the ID, right? So we have kind of this whole workflow of API calls that has to happen if we want to test that full function. And so this is why I'm excited for things like Arazo specifications, because Arazo specs are useful for defining these types of high level workflows from more of like a functional use case perspective. And so similar to how I'm thinking of open API specs as useful for testing the units, I think we can actually use these Arazo specs to power our integration and end-to-end tests. Um, and so the other cool thing about Arazo specifications too is, it's a specification which has its own rules and rigid structure. And like we talked about in cheat code 1, if we can use AI to quickly generate and maintain our open API specs, we ought to be able to use it to do the same with Arazo specifications too. And so, before when we're, maybe having to maintain all of these bespoke tests, things become as simple as let's just update the Arazo specification and then automatically generate all of our end-to-end tests based off of that thing. So think about those same AI prompts, right? Like I want to, based on my API specs in my code repo, I want AI to generate an Arazo specification that, let's say, fetches that user profile. And then hopefully we can arrive at that spec that chains together those three API calls to accomplish that. So I think there's some really, really cool opportunities here for using Arazo. That kind of summarizes the cheat codes that address a lot of the API spec challenges. So let's go back to kind of that other class of problems that we were talking about of developer productivity and our trade-offs with that inner and outer dev loop. So just to bring back those concepts again, right? We've got the inner loop, which we're running a lot. And then we've got that outer loop, which is kind of more tied to the CI, which we run few times, but is a lot slower. So our research that we've done shows that most teams are still running most components locally, like running and testing things locally. But there are trade-offs to doing that, right? So the more of our application that we run locally, we risk slowing down that inner development loop. But if we stop running as much stuff locally, we might be sacrificing the quality of our development environment in order to keep that inner loop fast. So I think this could all lead to that infamous "it works on my machine" excuse, right? So you've done testing and you think it's good to go and you push it out to the outer loop and then things are broken, right? But it worked on my machine. So how can we move some of that quality from that outer loop into the inner loop without sacrificing the speed? So that's where I think this concept of develop locally, test remotely really comes into play. So I think one proposal around this speed versus quality trade-off is let's try to set up a shared remote development environment. So imagine like a developer being able to run a single microservice that they're coding with all of its dependencies mocked out or running in this shared development environment. You could keep your inner loop going really fast, making quick changes, rapidly testing stuff out, without really sacrificing the quality of your testing. So this remote development environment no longer needs to exclusively run, or with a remote development environment, your app doesn't exclusively have to run on local host anymore either. It kind of opens up the opportunity for us to create shareable URLs and ways to preview changes that you're making to an API without having to commit your code and praying that it all works, right? So we're removing the burden of having to run your entire app on localhost, but still reaping some of the benefits of you know having a remote test environment. So let's dive into that a little bit more with cheat code 5. So if we are introducing these the concept of a shared remote development environment, um, I think that we should be trying to make these shared remote development environments as production-like as possible. So it's fast for developers, and we can make it high quality too, right? So think about the shared remote development environment, not only just running the components of your full stack application, but also running components like API gateways or other ingress components, data stores, mocked or even live third-party APIs, right? So when we think about how we want to set up our test environments, we usually try to mimic production as much as we can when we move from production to staging. And then I think we can move this into development as well. But the goal is, how can we get that high quality testing with all the production-like components before a developer has to even commit code and go to the outer dev loop? Many teams do have hybrid or remote and some kind of remote like tests set up. Maybe it's ephemeral test environments. Maybe they have a staging environment, right? But I think the goal is to try to shift that left as far as possible. And I think with the shared development environment, we can kind of get the best of both worlds there. So those are the 5 cheat codes. And I would encourage us to, remember that we don't want to get stuck missing API specs, right? Or even Arazo specs, or getting caught with slow development loops. So, when we're missing specs, can lead to a massive setback, especially in the age of AI. I think the organizations and teams who have API specs are going to be running laps around the teams who don't have specs. And then with development productivity, I think these are just little things that we can hit multiple times, right? That end up costing us in productivity in the long run. So we want to try to solve for both of those things. Yeah, keeping with the Mario theme here, us at Ambassador, we noticed this problem, and we wanted to try to give users that superstar power up to avoid those blue shells and banana peels, right? So we wanted to give people a power up for that API development. So we created Blackbird. So Blackbird is our new development tool. And it's this modular development tool that really tries to tackle both the API spec as well as developer productivity challenges, right? So what it is a place and a set of tools that can help catalog and discover API specs, produce API specs, and manage API specs, as well as offer this kind of shared remote development environment that developers can quickly use to run things like mock servers, deploy their code, and even test their code before they've even had to commit it. So we use AI to help power API spec creation and management. And we also offer a lot of dev-friendly tooling to kind of help people test their APIs and code changes before they've had to commit to the outer dev loop. We've got an IDE extension, a CLI. All of our features are very modular and can be scripted. And as most tools claim these days, we are AI powered, right? But it's really nice though, because as I mentioned in those first cheat codes, we can use AI to solve some of those really painful challenges that we've run up against in not having high quality API specs. So I would encourage everyone to go check it out. You can go to getblackbird.io and start a free 30-day trial of Blackbird, and come talk to me or reach out to our team if you have questions about it. Um, I would encourage you to try it out for free, and let me know what you think. And thank you so much for joining my talk, and I hope you found it useful. Take care.